Sodium sulfate is currently generated in large quantities as industrial waste in various industries, such as steelmaking, smelting, and battery production around the world. In developed countries, sodium sulfate is designated as hazardous industrial waste that pollutes the environment seriously. In terms of policy regulation, it is impossible to dump sodium sulfate in the ocean or bury it in the ground. In this context, the research laboratory led by Professor Myung-Joon Kim in Chonnam National University has developed a technology to produce sodium carbonate and sulfur from the wasted sodium sulfate. The sodium carbonate produced through Professor Kim's technology has various applications as a water treatment agent. Most importantly, this technology does not generate waste during manufacturing. Furthermore, it utilizes carbon dioxide, making it an environmentally friendly technology that can also secure carbon credits. This technology manufactures sodium carbonate using water with sodium sulfide, which is produced through the dry process of reduction roasting, and carbon dioxide gas from sodium sulfate. The technical process is broadly divided into four. 1. The reduction roasting stage. 2. The water leaching and carbon dioxide reaction stage. 3. The cooling stage. And 4. The sodium carbonate recovery stage. In the reduction roasting stage, sodium sulfide is manufactured by adding sodium sulfate and carbon. In the water leaching and carbon dioxide reaction stage, a sodium carbonate solution is produced by the reaction of sodium sulfide with water and carbon dioxide. In the cooling stage, sodium carbonate is crystallized. Sodium carbonate is recovered by filtration. It is an excellent environmentally friendly technology in that it achieves carbon reduction by utilizing carbon dioxide without generating any waste. We will introduce the details of the process subsequently. In the first step, sodium sulfate and carbon are homogeneously mixed in an optimal ratio. In the second step, the mixed slag and carbon go to the reduction roasting process at high temperatures in a rotary kiln to produce sodium sulfide. The carbon dioxide generated during this process is utilized in the subsequent processes. In the third step, the produced sodium sulfide is thoroughly stirred with water to create solutions of sodium hydrosulfide and sodium hydroxide. Then, carbon dioxide gas generated in the previous step is injected into the solution tank to precipitate sodium carbonate. The hydrogen sulfide gas can be converted into high-purity sulfur using the sulfur recovery technology which had commonly used by oil refining companies. It alone can be sold. This technology is already globally commercialized one. In the fourth step, the sodium carbonate solution is cooled. Using the property of sodium carbonate, which its solubility decreases with lower temperatures, the solution is cooled to a low degree of temperature using a cooler, thereby crystallizing sodium carbonate. In the fifth step, the slurry, containing precipitated sodium carbonate in large quantities at low temperatures, is separated into solid and liquid using a filter press. The solid sodium carbonate is recovered, and the remaining sodium carbonate solution is recycled into the previous step's water leaching process. Professor Kim's manufacturing method produces 0.75 tons of sodium carbonate and 0.23 tons of sulfur from 1 ton of sodium sulfate. This is worth approximately $400 or more. It produces sodium carbonate from sodium sulfate while minimizing operating costs. This process does not generate industrial waste, And it utilizes carbon dioxide within the process, achieving carbon reduction, ultimately making it an environmentally friendly technology. The research laboratory led by Professor Myung-Jun Kim in Cheonnam National University will continue to develop industrial raw materials that do not generate industrial waste, as a specialized laboratory for resource processing and recycling. In addition, we will take the lead in developing renovative processes for recycling industrial waste generated from various processes, actively implementing carbon-neutral policies to enhance industrial competitiveness. Thank you for watching with interest.